And I think now I can ask, because we've been, discussing about matter and theories of matter now. How did the whole antimatter argument come into play? Like, how did people, I mean, even though it's quite an interesting topic to talk about, and we will obviously, but how did we even think about there being an anti whatever we see? Like, how was
Right.
that process? What was that process?
So that process actually developed in the late 1920s, early 1930s. And in fact, the theoretical idea came forward first, and then the observations that
Okay.
the antimatter existed. So you have to go back to Dirac, Paul Dirac, the who the was this really this great mathematical physicist. And he was trying to develop a quantum theory that was consistent with special relativity. Okay, special relativity was agreed that it actually was real. Been around now for several decades. Quantum mechanics was only starting to develop, right? This is 1928, 1929. But Dirac actually started working on this idea of, well, how can you have a quantum theory that actually also agrees with special relativity, that incorporates special relativity? So he worked very hard on coming up with a set of equations, which are basically extensions of the Schrodinger equation, as we now know today. Or alternatively, the equation he developed, the Dirac equation, the Schrodinger equation is an approximation to it in the sort of non-relativistic realm.
Oh, I did not
So,
know that. Okay.
so his the what he discovered when he actually put together the mathematics was that, in fact, his theory predicted not only positive energy states but negative energy states, and that was actually a real puzzle. And in fact, it was seen as a failure of his theory because what is a negative energy state? It doesn't make any sense. But he then proposed that, well, maybe there's some ghost particles that are associated with those negative energy states. And in fact, what he realized was that if he actually thought of them as opposite in charge and opposite in all the quantum properties, you could actually think of them as actually real states, real energy states of a particle that was opposite to the ordinary particles. That was the idea. This was like in the early 30s. It was about a year and a half later that people actually observed an anti-electron. The
How do they do
and
that?
this was they did that because it actually comes out in a radioactive decay. You actually get a particle which is in fact the not negatively charged, but positively charged with the same mass as an electron. So the discovery of the positron took place after the theoretical idea came up, and that was then the uh, there had been this prediction by Dirac. The anti-electron or positron was discovered, and people then believed. Right? People
Wow.
actually realized that the Dirac theory was in fact had to have some validity to it, and people started calculating with it, and they saw that it was very successful in predicting phenomena. And that's exactly the theory or the equation that we use for all of all of our calculations in particle physics nowadays. It really
Wow.
starts from the Dirac equation as opposed to the Schrodinger equation.
Mm-hmm.
The
Mm-hmm.
So that's how we actually learned about antimatter first, and then eventually we actually discovered antiprotons. But that took actually quite a bit longer because you had to create them. They were not generated naturally in the nature. And you can understand that to a certain extent because there wasn't a radioactive process that
Mm-hmm.
created antiprotons. There was one that created anti-electrons. So you had to find a way of putting enough energy together to create an antiproton, for nature to create it by having enough energy density.
And
So
were they able to do this in like particle accelerators, or was it before that?
it was particle accelerators.
So
You
particle
needed to
accelerators
get
is what is when we saw our first antiproton,
right,
basically. Ah,
correct.
okay, okay. Wow,
The
the antiproton.